All right, ladies and germs, we're going to start planning out the work we're going to be doing to see if that shaker hood and that flapper being functional actually improves anything or will add any performance to the engine. So I'm sure you remember from previous videos, I added that second snorkel there to try to get more air into the intake. This is the factory setup here on the right hand side. The passenger side over there is what I added. So what I'm going to be doing is taking some measurements on some temperatures, and I finally found a good use for a Subaru engine, and that is to hold our clipboard. So what I'm thinking we're going to see is, so if we start our drive and we're going to plan out a route, I'm going to be taking the temperature of the carb, temperature of the ambient, temperature of the air duct on the fender to see if they're actually effective. I'm going to be measuring the temperature of the air into the rad, and I'm going to be taking the temperature of the coolant. And the reason I'm going to take the temperature of the coolant is I want to make sure this is repeatable, so I want to make sure that the coolant is fully warm, the engine is heat soaked, and we're up to normal operating temperature. So what I think we're going to see on our drive, the route I'm thinking of is probably about 7 or 8 miles, so that'll give us time, and it has a couple stoplights. So I think what we're going to see from an ambient point of view is hopefully we should see something like this. It may go up or down slightly. We're going to see the temperature of the carb. It's going to be likely some degree above ambient. And the reason we're going to measure ambient is because we may be taking these runs on different days, right? So we may have a different ambient temperature. So if we do it on a 40-degree day, obviously the temperature going into the carburetor is going to be a lot cooler than we did on a 70-degree day. So what we're going to do is we're going to reference all these to the ambient temperature and use what we call an ROA, which is rise over ambient. And so that'll allow us to compare apples to apples, all the data runs we take on any given day. So the temperature of the carb is, starting off sitting still. We're probably going to have stagnant air. It's going to look something like this. And as we get going, it should go down into a stable region. And this is that ROA, or that rise over ambient. Likewise, I think the temperature of the air duct is going to behave in a very similar way. Air into rad, I hope it's fairly stable. We want nice cool air going to the radiator, but with the fan and everything else, it'd probably be a little warmer than ambient. And then temperature of the coolant. So the temperature of the coolant will be way up top here, obviously, because ambient is not going to be anywhere near 190 degrees. So the temperature of the coolant will probably look something like this. And then as we stop and go into stoplights, you'll see the fan clutch cycling that temperature. So obviously as the radiator, the temperature of coolant goes up, that fan will kick in and then come back down and kick in. So when you're going smooth, we should see this radiator, this coolant temperature cool out there. So what we're going to get is, for example, we're going to do ROA, we're going to do stock, which for example is shaker closed and that single scoop. So we're going to get a rise over ambient. I'm just going to pick a number here of 10 degrees F. And shaker open. We're going to do stock. We're going to do, single and double scoop. Or single and double air intake, and then shaker open for both of those cases. And then we're going to seal off the air cleaner and just do a 100% shaker run. So what I hope to see there, what I suspect we'll see there, is some number lower than stock, right? Because it's allowing the engine to take air and out of the fresh air stream. So maybe we'll see like 4, for example. So I'm going to lay all those different configurations out, take these same measurements, and go from there. Also, inside the shaker, I'm going to take a pressure tap, and what I hope to do is see if there's any change in pressure between the stock, the dual snorkel, and then the shaker open runs to see if any of this air. Pontiac has a wind tunnel test at 50 degrees. I'm not sure if it's a marketing gimmick or not, but they show a high pressure area here you know, right where the windshield meets the cowl and then into the shaker. So we'll see at 50, 60, 70, 80, you know, whatever miles an hour, if we can measure a change in that pressure over ambient pressure. So just like the temperature, the ambient pressure rises and falls any given day. So what I'm going to do is I'm just take what we call a gauge pressure, not an absolute pressure. So the gauge pressure will basically just be the delta P over ambient. So that'll allow us, again, because I'm going to be taking these data sets over several days, that'll allow to correct that and compare apples to apples from different days of data. So we're going to see if this shaker open or closed causes any higher or lower pressure inside the scoop. And we're going to measure the actual temperatures, real world results we get from having that shaker open and closed in a single and dual and just a pure shaker intake. So that should be fun. Now I'm just going to start wiring up the sensors. Okay, ladies and germs, a little bit more about what I've done here. Been installing thermocouples, and I'm trying to decide a location to take the pressures from underneath the shaker scoop here. So I've got the sensor there for the coolant out. I have another sensor right here. This is for air in front of the radiator. I have another air sensor or temp sensor here. Sorry, it's a little hard to see. This little wire going in, and that's actually taking the temperature right on top of the carburetor. I've also installed a sensor here. I've always wondered if these NACA ducts here on the side, how much heat they actually reject. So I'm going to go ahead and throw a thermocouple in there as long as I'm taking all the data, see what kind of temperature rise we get from there. So I've run these thermocouple leads down to the floor. I've got them all labeled and everything, so I'm going to install them here on the data logger and get those things up and running and start doing some test drives. So I'll be taking temperature data of the ambient temperature, air in front of the radiator, temperature out of the NACA ducts or the fender vents, as well as actually temperature that the carburetor is taking in. And what we hope to show here, and we're going to correct for different ambient temperatures and ambient pressures for the atmospheric barometric pressure, and see if there's actually any benefit to the aerodynamics, creating a higher pressure zone when the shaker hood's open, and see if the factory, and see if any shaker opening can outperform the factory air scoop here. And again, I'm going to try it with the 2 scoops, the single factory scoop, shaker hood open, shaker hood closed, and then basically I'm going to do a final run with the snorkels completely blocked off and have nothing but the shaker open to see if there's any advantage of that setup as well. So anyway, once we get the coolant filled back up here, we're going to warm the car up and take it for a drive. All right, folks, getting ready to get on the highway here. Going to maintain 70 miles per hour and see what kind of pressures and temperatures we get from a stabilized carb inlet temperature. Obviously, as we start to sit, you can see the temperature start to climb under the hood. It's heat soaking, but I expect that carb in temperature to drop quite a bit from what we're doing here. So. All right, folks, just finished the first run. Noticed a few things. The max pressure recorded on the shaker hood was 0.28 kPa, which is almost nothing, obviously. Our next run, we're going to remove that tape and go shaker open. Something to note here is when you sit still, the carb in temperature starts to skyrocket. That's obviously due to the stagnant airflow under the hood and in through the scoops. So that stagnant air is just going to be heated by the surrounding air coming through the radiator. So anyway, going to keep on this, going to remove that tape and do our second run. All right, folks, just finished the second run. This is with both dual snorkels and the shaker open. I get my computer to wake up here, but the interesting thing to note is with the shaker open, the pressure, max pressure is measured at 0.14 kPa, which is still very, very insignificant, but you know, a lower pressure even with the shaker open, which I thought was pretty interesting considering the aerodynamic story from 1974. But anyway, I will continue on with these data sets and keep you all updated. We just finished the shaker closed single snorkels. This basically would have been the factory setup for the shaker hood and for the intakes. Pressures were definitely a little lower, and what was strange is that the pressure during most of the drive was actually negative, which means that the carb was kind of drawing more air into the air cleaner than what was coming to the snorkel. So the pressure was slightly negative through most of the trip. So anyway, we're going to take this tape off the shaker hood, open it up, and do a run with the shaker open. Okay, just finished shaker open with the single scoop. No real dramatic change in pressure. The temps look pretty similar to what we had before. So now we're going to do the final run, and we're going to block off both scoops and do it purely through the shaker. So we're going to block those off and get started on the next one. So that's both snorkels closed off with tape. I knew you'll be very impressed with my tape job, so there it is. So this run will be done with both of those snorkels closed and then that shaker hood open. So after we finished taking all these data runs, I downloaded the data from the data logger and imported it into Excel. From there, I graphed it, looked at the data, looked at all the results, made sure it made sense, made sure all the sensors were in range, et cetera, et cetera. So won't bore you with all the details for each of the runs, but I'll show you a summary of the results from each of the tests. All right, looking over the results of the data, it's important to note the route that was used on each of the runs. So the starting point was right here at this corner. It's an intersection. It has a 4-lane highway going 60 miles an hour. with a stoplight. That's what this cross means. And then it's got a 3 mile and then a 4.5 mile stretch of highway with no stoplights. So the Pontiac wind tunnel test was done at 50 miles an hour. So I wanted to have runs at 50, 60, 75 to 80 miles an hour here and back to 60, just to make sure I was over that 50 mile an hour threshold, just to take the benefit of any of the high pressure zones that Pontiac bragged about back in the day. So most of the time I got these 2 stop lights. I'll show you what that data looked like, but this route was used consistently in all those runs. So from the data, this is an example of one of the output graphs. We had our here, this blue is the coolant temperature. So you can see here, this is in our 7.5 mile an hour zone here. We got these nice stable temperatures. So the coolant, here at this, you can tell this is at a stoplight. This is the actual fender vent temperature here, and this is the actual rad in. So the temperature of the radiator was definitely affected by this thing coming into a stop and the fan kicking on, and that's when you see the spike of temperature coming out of that fender vent. So with that fan on, I think anybody with a Trans Am knows, sitting with your elbow out the window, you can feel that warm air from that fender vent. So it's obvious those fender vents are extremely effective. So, but again, out on these this nice smooth stable temperature zone here is where we got our ROAs, and these bottom 2 graphs actually are those rise over ambient. So this maroon here is the fender, and then this is the carb. So you can see here, with progressively running this, looks like this is about a 71 degree ambient, something like that. Got nice stable, very low ROAs here with the dual snorkel shaker closed here. So also important to note too, as that stopped, you can see that the fan kick on, your fender vent temperatures shoot way up. And then when I stopped to get ready for the next day to run, I would leave the recorder on, and you can see here again that fender vent working overtime with the engine stopped. And more to the point, you can see the carb temperature start to climb, and the ROA get worse on the carburetor as well, as like your air cleaner, the lines, all that are getting heat soaked, the air cleaner itself. So as it's sitting stationary, you're not flowing much air through the carburetor, so it's getting stagnant. So when you're just sitting there with a hot fan blowing on it, it's the air temperature is going to continue to climb until you get moving again. So I don't think it's any big surprise there, but the data, I think, told a pretty good story about the effectiveness of the fender vent, and I think we got really good data on the temperatures into the carburetor. So if we actually look at the results, I looked at the data sets in min, max, and average point of view for each of the snorkel and shaker closed in the shaker open side over here. So basically, the dual snorkel shaker closed had the worst performance in terms of it had the warmest air intake, that rise over ambient temperature in that ROA zone I showed you. Had a max of 35.4. Again, that's when it's heat soaked at an intersection with the fan on, and an average about 16.6 degrees over ambient. So the fender vent performances were pretty common amongst there. You can see, it just was very effective at getting hot air out from underneath the hood. The best case scenario we had for getting the air intake temperature as close to the ambient probably is a surprise to no one. It's the shaker open. Both of those snorkels blocked. We got down to about 1.5 degrees to the ambient temperature. It was actually pretty darn good. You'll also note here that it also had a very high average for max. And what I saw in the data is on the shaker open, when you were stopped, I think there was, since all that air was being drawn into the snorkel, it was drawing some recirculated hot air in from under the hood, like where the cowl meets there. There's a good bit of air coming up through there. So I think since it was forcing to draw there from that cowl area when you were stopped, I think it was recirculating hot air. So I think it falsely made this max higher than what it would have been. But I can say with confidence that shaker open with no snorkels, we actually got our best rise over any air temperature. So the difference of, basically 6 degrees from there, that it would be a measurable difference in horsepower between those two. So I think you can definitely say that the shaker open no snorkel has a performance advantage. The only problem with that is obviously in rain and inclement weather, you wouldn't want to be sucking in water and snow and things like that. So having the ability to open and close the the shaker is important, but there's some clearly performance advantages of it there. So let's talk about pressures real quick. The pressures that were measured here, honestly, I think are likely noise. They're well within the measurement capability of the equipment, but I don't think there's any compelling story here that says that one air cleaner setup, whether single or double snorkel or open or closed, will produce any significant air intake pressure or any ram air effect, or however Pontiac advertised that in their that high pressure zone there, where it shows you where they show the high pressure zone there at the shaker. So I don't buy that it actually has any positive effect on pressure. Like I showed you in the route, definitely hit speeds at or above what they claimed in their aerodynamic study. So I think we can safe to say that the pressure part of it, I think, is just kind of a marketing gimmick. But I think there's a real world benefit to having the shaker open and having that lower intake temperature. It's funny looking over the data, having known what I know now. I added that second snorkel thinking there's going to be some performance benefits to having extra air going to the cleaner, but looking at the actual hard data, it looks like the single snorkel with the open and closed shaker outperformed my dual snorkel setup. So if I get my time machine, I probably wouldn't have gone and done that, but I still like the look, so I'll probably still keep it on. But I can just open up that shaker whenever I want and have all the performance I need out of that. And also make some pretty cool 4-barrel noises having that shaker open. So I'm going to enjoy it both ways, and hopefully you enjoyed this video.